Hello and welcome to Chemistry Nuggets, where you can polish your knowledge and clear those. So friends, today's video is question number 2.18 from NCERT textbook class 11 and the chapter name is Structure of Atom. Let's check the question. What is the energy in joules required to shift the electron of the hydrogen atom from the first Bohr orbit to the fifth Bohr orbit? And what is the wavelength of the light emitted when the electron returns to the ground state? The ground state electron energy is minus 2.18 into 10 to the power minus 11 ergs. So friends, first understand the question. Here they are talking about a hydrogen atom. Suppose this is a nucleus of hydrogen atom and this is first orbit and somewhat here it is a fifth orbit. So this is n is equal to 1. Here energy also it is E1 and this is n is equal to 5. Energy here it will be E5. Electron is in first orbit. It goes to fifth orbit. So they are asking in this transition of the electron from first to fifth orbit, what should be the energy required? That we need to find. First thing. Second thing, we need to find the wavelength of the light emitted when electron is coming back from fifth orbit to first orbit. So first of all, we will find the energy in joules. As we know, del E, it should be E5 minus E1. For Bohr's model, we have the formula del E is equal to minus 2.18 into 10 to the power minus 18. 1 upon n final square minus 1 upon n initial square in bracket and z square. The unit is joule. This is the formula for the energy required to shift from one level to other level. Here n final means the final state of the electron. Finally electron reached to fifth orbit. So it will be 5. And n initial is the initial state of the electron, that is first orbit. Here in this electron is going from first orbit to fifth orbit. So these are the values. Z is the atomic number of the hydrogen atom. It will be 1. Now put the values minus 2.18 into 10 to the power minus 18. 1 upon n final is 5. It is 5 square minus 1 upon 1 square, n initial is 1 and z value is 1 square joule. Now start solving. Minus 2.18 into 10 to the power minus 18, 1 upon 25 minus 1 upon 1 and 1 is cancelled, joule is there. Now inside the bracket 1 upon 25 minus 1 upon 1, solve it. 25 1 minus 25, it will be minus 24 by 25. Putting this value, minus 2.18 into 10 to the power minus 18 into minus 24 upon 25 joule. Now minus will be cancelled and the final value will be, it is 2.0928 into 10 to the power minus 18 joule. This will be our answer for the energy required to shift the electron from first orbit to the fifth orbit. Here plus value shows that energy is absorbed. If the value is in minus, then it means the energy is emitted. So here from going from first orbit to fifth orbit, energy should be supplied. In the terms of erg, if we are going to write, we knew that 1 joule is equal to 10 to the power 7 erg. So we can write it 2.0928 into 10 to the power minus 18 into 10 to the power 7 now ergs. So it should be 2.0928 into 10 to the power minus 18 minus 18 plus 7, it will give minus 11. We can write 10 to the power minus 11 arc. So friends, this value is in joule. This is also correct, and this value is in arcs. This also correct. Both the answer are correct. So our first part is finished. Energy in joules is, we find it. Now next part is wavelength of the light emitted. So for this, first again we need to find the positions of the electron. Here electron is coming from fifth orbit to the first orbit. So n initial will be 5 and n final will be 1. Because starting state is fifth orbit and ending state, final state is the first orbit, ground state. Now formula for wavelength, we knew that wave number 1 upon lambda, its formula is minus 1.9097 into 10 to the power 7. Again 1 upon n final square minus 1 upon n initial square into z square, and the unit is per meter. Now putting all the values correctly, minus 1.097 into 10 to the power 7. Now 1 upon n final is 1 square minus 1 upon 5 square, and z is 1 square per meter. Now solve this. Minus 1.097 into 10 to the power 7. 1 upon 1 minus 1 upon 25 per meter. So let's solve it. 1 upon 1 minus 1 upon 25 will get 25. 25 minus 1, it will be 24 upon 25. Now putting this value, 1 upon lambda is equal to minus 1.097 into 10 to the power 7 into 24 upon 25 per meter. Now we need to find lambda. So we will turn it as a numerator. So all the units will be turned, all the equation will be turned. So 25 will go up and minus will be there. 1.097 into 10 to the power 7 into 24 will go down, and the unit is now meter. Now this meter we can turn to angstrom, as 1 meter is equal to 10 to the power 10 angstrom. So we can write it here, minus 25 into 10 to the power 10 divided by into 10 to the power minus 7 from denominator, we can write it here, 1.097 into 24. Now it is angstrom. Now going to solve this, we'll get the final answer. Now lambda, it will be, after doing all the calculation, we'll get minus 949.5 angstrom, and this is our answer. The wavelength of this transition from N5 to N1 is minus 949.5 angstrom. So friends, that's all for today in this video. The question is now solved easily. The concept is very easy. So do like, share and subscribe, and don't forget to subscribe the channel, as you can get the notification for the next coming video. Till then, thank you.